For almost 5 years, the Curiosity rover has been exploring the bottom of Gale Crater on Mars. But if you look far enough back in time, you would not be able to explore it with just a rover. You would need a submarine. You wouldn't be looking at Gale Crater anymore. It would be Gale Lake. Scientists think that an ancient sea survived there for around 700 million years, from around 3.8 to 3.1 billion years ago. And in a new paper out in the journal Science, researchers used what Curiosity's learned about the rocks in Gale Crater to put together a history of the ancient lake. The results suggest that the lake had two distinct layers, each with its own chemistry, and for those 700 million years, the conditions in the lake probably would have allowed life to survive if it ever did evolve on Mars. With the water long gone, the researchers needed to look for clues left behind in the planet's rocks. Rivers and lakes are full of floating particles which settle onto the bottom over time to form sediments. Over time, these sediments pile on one another, with each layer corresponding to a different period in the lake's history. Eventually, the immense weight of these piles, plus the water above them, starts to compress the lower layers into solid rock, called sedimentary rock. Essentially, sedimentary rocks are the fossilized remains of the lake bed, and on Earth, that's where we find most fossilized life, like dinosaurs. Even though we haven't found any evidence of life, Gale Crater's sedimentary rocks can tell us a ton about what things were like in the lake billions of years ago. Normally, to get to this ancient part of the rock record, you'd have to dig through kilometers of solid rock, which would be pretty tough for a car-sized rover. That's what made Gale Crater an ideal landing spot for Curiosity. There's a giant 5.5-kilometer tall peak smack in the middle of it, named Mount Sharp. Mountains are like time machines, exposing all that old rock for easy viewing. So to study hundreds of millions of years of history, all Curiosity needs to do is drive up the side of Mount Sharp and analyze the rocks in different places. When the researchers put together all that data, they found that Gale Lake was stratified, meaning that the water formed distinct layers, and those layers had different amounts of oxygen. Plain oxygen was poisonous to early life on Earth, but compounds containing oxygen, like iron oxide or manganese oxide, might have been helpful for early forms of life as we know it. With its varying levels of oxygen, Gale Lake could have had some of those compounds, which would have provided some life-friendly habitats. The team also found that the Martian climate above the lake changed over time, bouncing between colder, drier conditions and warmer, wetter ones. But bodies of water can make environmental changes like these less extreme. So despite the changes happening on the surface, the lake itself might have stayed habitable for long periods of time, a hopeful sign in our search for evidence of life on Mars. Meanwhile, other astronomers are learning about mysteries much farther from home. In another recent paper published in the journal Science, a group of researchers studying a distant star did something remarkable. They proved Einstein wrong. Well, they proved him both right and wrong. More than 100 years ago, Einstein described how massive objects like stars bend the fabric of the universe as part of his general theory of relativity. One of general relativity's coolest predictions is that the light from far-off stars bends as it passes objects closer to us in what's known as gravitational microlensing. Basically, a closer star's gravity can act as a lens for the light from a more distant star, which leads to two major effects. The background star can look much brighter than usual, and it can also look like its position shifts a little in the sky. Einstein thought these effects would be too small for us to ever observe them, but he had no idea that we would develop space telescopes and digital imaging techniques that are impossibly sensitive compared to the photographic plates of his era. For decades now, we've been able to observe the brightening that comes from gravitational lensing, but one part of Einstein's prediction remained stubbornly true. We just couldn't see that shift in position. It's rare for stars to align in just the right way, and even when they do, the shift is so small that we haven't been able to detect it, at least until now. Using the Hubble Space Telescope, the team saw one star change the apparent position of another for the very first time. In the process, they proved Einstein's prediction wrong, but they found more evidence that his theory is right. They also cleared up some major confusion about the star used as the lens. Stein 2051b is one of the closest and best studied examples of a white dwarf, which is what stars like our sun turn into at the end of their lives. But scientists have been really confused about its mass. Based on its radius, 2051b should weigh about 2/3 as much as our sun. But previous estimates put its mass at only about half of the sun's, and That is a big difference. For a star with 2051b's radius and that lower mass to form, it would have to start off incredibly hot. In fact, some estimates suggested that in order to cool down to its current temperature, 2051b would need to be as old as the universe itself, which made no sense since our galaxy is about 600 million years younger than that. Based on how 2051b bent that background star's light, the researchers were able to get a much more accurate measurement of the white dwarf's mass. And it turns out that it does weigh about 2/3 as much as the sun. That's a win for understanding the lives of stars and a win for general relativity. All around, a pretty good day for astronomy. Thanks for watching this episode of SciShow Space News, and thank you especially to our patrons on Patreon who help make this show possible. If you want to help us keep making stuff like this, you can go to patreon.com/SciShow. It's just a place where you can give us a little bit of that coffee money. You don't need that coffee. What's that? It's just gonna make your stomach upset. That's how I feel. I love coffee. Also, if you want to support us just by watching and sharing, that's fantastic. You can find us at youtube.com/SciShowSpace.